I'm Simon. I'm still awake.
What are you trying to say?
Nothing. So I work in the AI and apps innovation team, predominantly in the retail sector, so working with perhaps a number of retailers that you use every day, helping them do interesting things on our platform. I'm also interested in green software. Anybody familiar with green software? No one? One person? Cool, that's good then. So part of this will be to tell you about green software and evangelise it. I'll probably spend more time on that than anything else. So I've been interested in green software for maybe about 6 years or so now. Both internally within Microsoft, I'm part of a bunch of internal groups where we figure out how we can improve our software from a sustainability point of view, but also how we can take those messages out to our customers. So I was one of the authors of the sustainability pillar of the well-architected framework. I'm going to start with a why, because it kind of follows on from what Tom was saying, which is Microsoft, Google, AWS, all of the cloud platform providers are doing as much to improve sustainability as they possibly can. So why should you care? Why should you not just use those platforms, deploy your solutions, and inherit all of those good sustainability attributes? And really, there are two ways of thinking about that. One is, it's a shared responsibility. I think security is a good analogy. When we talk about security in the cloud, we talk about shared responsibility. We will do everything we possibly can to improve security. But if you go and deploy something on our platform that is not secure, it's not secure. It's a shared responsibility. And the same is true for sustainability. The demand is growing like never before. We can just look at AI as an obvious example, but other examples over history, COVID. Remember the headlines in COVID, the demand for the cloud because of the use of things like Teams shot up. We were having to prioritize first responders because the demand for compute was huge. So if you can take your responsible side of things and help us, as Tom described earlier on, then it helps the entire environment. Technology is helping this, things like containers and Docker. It's helping us improve the density of the use of compute, but there's still the demand is still there. So I'm guessing that you've not heard of Green Software Foundation. Green Software, you've not seen these before. These are the Green Software Foundation principles. Anybody seen them? I will probably. Oh, one person at the back. Cool. Excellent. I'll probably spend a little bit longer on these than I intended, and we'll concentrate on this. So, Green Software Foundation is an external organisation focused on, surprisingly enough, green software. And it's really thinking about how to evangelise and educate and give guidance to anyone building software on how to think about sustainability. And you might look at some of these, and we'll go through them, that they're a bit blindingly obvious. And they are. But if we were to use cost as an analogy, 15 years ago, people building software were not really thinking about runtime costs. Because everything was implemented on premises, on stuff that was already purchased, and they just build software and they deploy it on the machines and run. That's not true today. You saw on one of the slides that Tom showed that everyone knows what the cost of their applications are. And any changes to those applications, they know the impact of that cost. Come forward 15 years, and this is where we are with sustainability and emissions, and we're having to educate again and raise the awareness, the level of responsibility, the shared responsibility that people building software has. So we've got three buckets. We've got carbon efficiency, think about hardware, think about carbon awareness. Carbon efficiency, this is the obvious one, right? This is think about the carbon emissions when designing your solutions and building your software. Think about it. Same as cost. And then we've got energy efficiency. energy efficiency, you saw on that previous slide there, a machine has to be turned on. If you've got a web server, it has to be turned on listening for web requests. But if it's not doing any meaningful work, then it's wasting energy. So energy efficiency is about doing meaningful work for every unit of energy. We call it energy proportionality is another way of thinking about it. So if a machine's on, do something with it. Carbon awareness. This is ultimately where we want to be. So if Tom set this up as perfect.
You might have to drag it over.
Oh. Cool. So anybody familiar with carbon intensity? Still the same person. Cool. So this is energy maps. Electricity maps, and this is showing the carbon intensity of different grids over the world. Carbon intensity, side comment, carbon. We say carbon all the time. We actually mean, if you look at the formula down here, this is grams of carbon dioxide equivalents per kilowatt hour. So we just say carbon as a moniker for all bad greenhouse gases. We just say carbon, it's everything there. So this is basically saying that if we look at the UK, and that pops up, this will tell us it's green, so that's a good thing. So within the UK geography, the carbon intensity at this particular moment in time, when it pops up, is 94. So that's a good thing. So there are two variables here for carbon intensity. One is geography, and the other one is time. So what do we do with that? When we're thinking about running our applications, we go, do we need to run them in the UK at this particular time? If we don't need to run them in the UK, because if perhaps the UK the carbon intensity wasn't great, it's actually quite good at the moment, we could go run them somewhere else, so we could move the geography. If we do need to run them in the UK because of sovereignty reasons, whatever, keeping the data there, do we need to run them at this particular time? And of course, for business reasons, for compliance reasons, sometimes you actually do need to run it at this particular time. But if not, maybe you could run it later today, when carbon intensity is better. So that's carbon awareness, and that's the ultimate goal of applications, is to make our applications carbon aware, so we can make decisions on when we run those applications and where we run those applications. Then we've got hardware efficiency. Not just mobile phones, all hardware. There's this thing called embodied carbon. Embodied carbon is the amount of carbon emitted during the entire life cycle of this particular product. Now, the Green Software Foundation came up with this formula of measuring the carbon intensity of software, the SCI formula. And it was agreed that we had to take into account embodied carbon in that formula. So when you are running your software, if you want to calculate the efficiency of that software from a sustainability point of view, you have to take into account embodied carbon. So what that really means in a hardware efficiency point of view is, do not make me throw this phone away and buy a new one. Make your software run on this phone. And then we can make that software more efficient because it's reusing that technology. Measurement, Tom's already touched on that. There are two methods of measurement. One is the greenhouse gas protocol, scope 1, scope 2, scope 3. That's kind of like this size, which is really interesting from an organisation, but from a bit of software, it's sort of less useful. It's very difficult to use that to figure out the emissions of software. I've touched on it already, the SCI, the Software Carbon Intensity Formula, now in ISO. That is a formula that we can measure the emissions of our software. We need to be able to measure it because if we want to change it and improve it, we need to be able to measure it. And then we've got climate commitments. Again, Tom touched on these. It's important to understand the mechanism that you are making for climate commitments in order to help improve those as an individual within your organisations. There are many tactics and many approaches for that. I just wanted to flash these up. I touched on the bottom one, electricity maps. There are APIs available in order to go and figure out the carbon intensity. It's pretty easy to forecast it as well, so you can make these forecasts on when you run your software. Microsoft itself uses the What Time API. For those of you who are running Windows machines, if you hit the Windows key, type an update, it'll come up with the Windows Update screen. Towards the bottom, there'll be a little sentence that says, we use What Time in order to figure out what the carbon intensity is in your location at the time you want to run your updates to figure out whether we should run those updates or not. So, AI, where does that fit in with all of these principles? So, we touched on this already, and I'm probably teaching people to suck eggs, but there are a lot of overloaded terms here. I just wanted to get some clarity on those terms before moving forward. First of all, training the base model. You know, not many people in this room will be building their own models. You'll probably be using models from the providers out there, you know, whether that's Anthropic, Microsoft, whomever it happens to be, and probably using large language models, particularly if you're forecasting weather, because they're so good at doing that these days. I never cease to be astounded how good they are for most things. But then you've got fine-tuning. So you take those base models that somebody else has done and you fine-tune them. You fine-tune them on your knowledge. So just a side comment, models. I think about models in two ways. I think models has intelligence and it has knowledge. The knowledge is only relevant within the base model at the point of training. So if I trained the model 5 months ago, it doesn't know what happened last week. Pretty obvious, I know, but if you think about it in those ways, then you can use the intelligence using fine-tuning, but you give it the knowledge that you want it to be aware of. And then you've got an end product that you can go use. Then we've got grounding. Grounding is, again, giving the model knowledge, but it's giving it at runtime. So you can do that through prompting, so I can tell a model how to behave, I can give it a little snippet of information in order for it to be aware of something. Or I can use a pattern called, anybody heard of RAG? Yeah, most people, fantastic. So retrieval augmented generation, I actually go select the top 10 customers from my customer database, grab them, give them to the model along with any other context, along with a question, and I get the model to go answer that for me. It's pretty obvious that because most of us will not be building models, will not be training models, we don't really have any control of that. We actually get to use the model. We're consumers of the model, which is on the right-hand side. You can impact how you use those models. These are the ways. In the early days, particularly in 3.5, GPT 3.5 from OpenAI came out, we just used the latest and greatest models. Because they were the latest and greatest, they were really, really good. However, because they were the latest and greatest, they were the biggest models, they were the most expensive models, they took the longest latency to give you an answer, and now we have more models. We have specific models. So use the correct model for the task that you've got. Many customers that I work with will use 3 or 4 models within one solution for the right particular task. And you can do that manually as a developer. You can choose which model to use, or you can use a model router. And a model router will give it the question, give it some context, it will figure out which model to use on your behalf. Or you can use an orchestrator such as AutoGen, LangChain, Semantic Kernel, Agent Framework. These are all orchestrators that will use a model to orchestrate a workflow in order to help you answer the question that you are asking it, and it will figure it out itself in a very intelligent way. You have to be careful because models are quite chatty, like to talk with each other, and yeah, you just have to have a bit of control of that. Container token usage, you know, tokens, everybody's familiar with tokens, maybe not familiar with tokens. Everybody is familiar with tokens, yeah, so cool. So think about the tokens, don't give it too much context. A lot of packages will give the models as much context as it can, as it knows about. And tokens are in and out. I'll wrap up because I think we're on time. So Tom alluded to this, highly recommend it. It talks about what I've said, but in kind of more business terms. It's recently announced a couple of months ago, so I highly recommend that. We've got some guidance in the well-architected framework for sustainability. Go take a look at that. The Green Software Foundation has a bunch of patterns. The catalogue we recognise is not that well structured, but it does give some guidance on particular problem domains, on how to go and think about them in a sustainable way. One of the things that I've not touched on is actually using AI within the software development lifecycle, i.e. vibe coding, if you want to think about it in that way. Because everyone's a developer now. The new development language is English. But it is efficient. The models now are so good at predicting weather, they are so good at writing code as well. You know, they can come up with energy efficient designs if you prompt them in that way. They're really good at iteration and working through them and basically reducing complexity, which usually equates to reducing the energy consumption of your software, which is ultimately the goal at design time. And then, of course, as Tom gave the example about Copilot reading and summarising the document much quicker than a person. You know, these models can write code much quicker than a person can. So again, you're reducing energy. GitHub has a whole bunch of guidance for sustainable software development, so highly go recommend that.